Okay.
It was like rice and brown.
All right. So, I got, 1A and 1C were easy. I just plugged in 4 and plugged in -2. Now, it was a picture that I was plugging into, and I had to be careful. Did you catch that some of those dots were open and closed? So your function value is always going to be the closed dot. So for G of 4, I got 3, and for G of -2, I got -3. Is that what's happened for you? Okay, now, oh shit, it's drawn over there. For 1B, I wasn't sure what was happening, so I went ahead and sketched 1B by factoring and all that stuff, so I gotta reproduce it over here so it's on video. So I got an asymptote horizontal at 3. I got a vertical also at 3. What else did I have in that? I had a hole at 1, -15/2. And I think I plotted an intercept. My x-intercept was -4. So based on that, I felt really confident. Oh, that's not good. I felt really confident in this picture. Are you okay with that? So when it said, what happens as I approach -infinity, I said, the answer is 3. Because aren't we getting closer to 3? Now, technically, we're getting closer to 3 from the bottom, but that doesn't suit this particular problem. I need a number, so 3 is my number. So the odd one out is the -3. So I'm keeping track of my odd ones out. Is that okay with everybody? All right, number 2, F, which is this guy right here, has a hole where X is 1, because when I simplify problem F, I can cancel out the 1s, right? Everybody good with that? G has a hole where? Where is the hole for function G? Be careful. It's -2. Now, why is the hole not at 4? Because to be a hole, your curve has to go through it. So it looks like this, in other words. The curve is on both sides of the hole. So you can have other kinds of discontinuities. What's happening at 4 is called a jump discontinuity because you jump up. The only hole is at -2. And then H, I did H, I factored it and canceled. It has a hole at -2. So the odd one out was 1. All right. Have you gotten to the rest of these yet? I don't know how far you worked. Did you do some of how long? No. All right, so 3A takes us back to H. And H is this one. This is H. And I need the limit as x approaches infinity. What's the limit as x approaches infinity? 1. And then what about -infinity? Same curve, -infinity. Still 1. Now I know that one of them's from the top and one of them's from the bottom, but we're looking for a number. We're looking for the number, and the number is 1. And then what about G? G is the one you have a picture for. What is the limit as you approach -infinity in G? -1. So that's your odd one out, would be the -1.
Miss Ford, I know it doesn't matter for this, but for G, what would you say it's from the top or from the bottom? Because they're like,
So which one are you talking about?
3C.
3C?
Like as it
One
approaches
negative
-1, would you say it's from the top or bottom?
The limit as x wait, where's G?
Or it's
Yeah, so G is the picture, so we're approaching -1 from the top.
Okay.
It's on top of the asymptote.
Okay, even
Right.
though it comes up like that.
Yeah.
Okay.
No, we're talking about as x approaches infinity. So we're looking at what happens out there to the left. Okay, 4 is all about zeros. So f of x has a 0 where? Well, this is my picture of f, I think I should write there. At least this is part of f. And what's it mean to be a 0? You are crossing the x-axis. Doesn't that happen at -4? So f has a 0 at -4. G of x equals 0 for which integer value of x? So in other words, what's the 0 for G? G is our picture. G has a couple of zeros, but the only one that's an integer, -3. And H has a 0, H has a 0 right here, -3. Remember, zeros come from the numerator, -3. So what's the odd one out there? -4?
4A.
4A, -4. All right, everybody okay with that? All right, 5. I'm back to H, so I'm back to this guy. And I want to know what's the limit as x approaches -2. All right, everybody, look at function H. Factored, canceled, here we go. Tell me what's happening in H at -2. We got a hole. So what's happening? Doesn't matter which way we come from, as we approach that hole, that's our y value, right? This is -2 comma something, that's the limit. So what is it? I got -1, but I don't know if I did that right.
That's right.
That's right, okay, so that one's -1. Now I'm looking at my G picture, which is the one they drew. And as we approach something from the left, we go up. So that something must be an asymptote. So if I'm looking at G, coming in from the left and going up, it must be 7. Would you agree with me? And then f of x equals -9 when x equals what? Well, that is kind of a tricky one. What are your thoughts about that? We want f, this was f right here, and we want f of x to be -9/4. What do you think?
Do you use the equation where x is less than 2?
Is x less than 2?
Yeah.
Yeah. So we're going to use the equation where x is less than 2, which is this guy right here. Right? And we want that to equal, that's the reduced version. We want it to equal -9/4. Can we solve that? Yeah. All right, let's go ahead and solve it and see what we come up with. Boy, I don't know. I don't think that's right. about what?
-1.
-1, that would make sense. What did I do wrong?
How'd you get 3x? You just cross multiply.
Okay, where'd you get 3x?
Oh, that should be 21x, thank you, yep, there's where my mistake is, yep, I got -1 also, yep. Yep, good job. Remember, F has 3 different pieces to it, so does everybody understand why Kellen said we gotta use the top one? Because that's where our X value matches. Alright, so, the odd one out there is B, 7. And finally, number 6, the domain of F. Okay, this is F. Yeah, so the domain of F is X can't be something. What is the something X can't be? What? 1. I heard 1. Do I hear any others? I was hoping somebody would say 3. This is a tricky situation. This graph is the graph of the top part of function F. Look at the top part of function F. X has to be less than 2. So is the 3 even part, is that X value even part of the top part? No. So it's where the hole is. Yeah, that's where it's not defined. So that's 1. Average rate of change of G over the interval -2 to 4. All right, so G is drawn. G is drawn. So G of 4 minus G of -2 over 4 minus -2. Would everybody agree with that? What's G of 4? 3. What's G of -2? -3. Did you get 1? So that's 1. H of X, that's this one. H of X has a vertical asymptote at -1. Kind of a good exercise, got us thinking about a lot of stuff. You okay with that? All right, what I want to do right now is, what question do you have? Because tomorrow we're going to have our little quizzy poo over all this stuff. And it will be modeled after the review sheet we did yesterday. Remember the review sheet we did yesterday that I wrote? All right. That's what it'll be modeled after. But basically we have to know everything. So what homework you have a question about? What? I don't know, notes, what? Anything. Otherwise, we'll just start in. You've got one more review sheet to do. And we can do that next. Declan?
have like a unit 1 test.
No. We only have, the units are too huge. So there's no way to have a unit 1 test. It would take multiple days. So we don't want to do that. So the quizzes accumulate in unit 1. So 1-1 to 114 is tomorrow. But they're quizzes, so they're not 100 points or anything like that.
Is there like a copy of their information on Canvas?
I don't know, but there's probably one back there.
Alright.
It could be on Canvas, I can't remember.
Do the quizzes for like the next unit add on, like will we have like a quiz over 1-1 to like 2-3?
No, unit 2 will be separate. And then at the end of the year, we will start reviewing, and then during that review, all of it will be together. In one big huge thing. Because that's what you're saying, Alex.
Can you do question 5 on homework topic?
At 1.12 homework, question, 112 homework, question 5. There was a graph like this on yesterday's review, if you'll recall. So number 5. So are you talking about this one, negative 2 after x plus 1? Yeah. Okay. So I'm gonna look, okay, first of all, let's make sure we're clear on what's happening here. What are the changes that are happening to function f? First of all, we're going left 1. So in other words, I'm taking my x's and subtracting 1. I'm taking my x's, subtract 1. Okay, what else is happening? I am multiplying my y's by negative 2. Now that accomplishes 2 things. It makes it twice as big, and it flips it upside down, okay? So I'm gonna look at my original points in my original graph. So these are my F points. It looks like I have negative 3, 1, and negative 1, 3, and 2, negative 1, and what is that one further? 1, 2, 4, 2. And I think that one's 5, negative 1. Aren't those my original points? Okay. So now, for my new points, I'm going to take all my x's and subtract 1. So negative 4, negative 2, 1, and 4. So for my new points that I plot, these will be my x's. My y's are getting times by negative 2. So that will be negative 2, negative 6, positive 2, and positive 2 again. So then I'll plot those points. These are the ones I want to plot. So negative 4, you've got a grid there to do it, but negative 4, negative 2, negative 2, negative 6, 1, 2, and 4, 2. So it looks something like that, Alex. All right? All right, anybody else have a question about something?
On that same homework, can you do number 3, B?
Which one?
B, number 3B.
3B. 3B. All right, this idea of average rate of change is huge. So we're gonna find P of 1/2 minus P of negative 1/2 over 1/2 minus negative 1/2. Does that setup look okay to you? Okay. So now I need to know what P is. I don't know what P is. So let me figure that out. So P is what? What am I doing? A horizontal dilation by a factor of 1/2. What does that mean? What's happening if I have a horizontal dilation of a factor of 1/2?
Multiplying the x's by 2.
Yep, so I'm gonna have, what is it, F, G. So G of 2x. All right, what else is happening? A reflection over the y-axis. So that's actually a negative 2. Remember, if you put the negative out in front, Fred, that takes you upside down. That's the x-axis. Okay? And then vertical translation by 1. So this is P. Now I want to find P of 1/2. So P of 1/2 is going to be G of negative 1 plus 1. And G of negative 1 is 2. So this number is 3. Is that okay?
Yep.
All right, and now I gotta find P of negative 1/2. So that'll be G of 1 plus 1. So g of 1 is 6, plus 1 is 7. So it looks like -4, my average rate of change is -4. There's a lot going on there. Did everybody follow all that? And did we learn from Fred? If you mess up your equation, of course you're gonna get wrong numbers, right? So we gotta be really careful when we build that equation.
Homework, 1, or 2C.
Same homework, 2C. Yeah, we talked about this. What do we know about inverse relationships? We know that if f of 5 is 9, then f inverse of 9 is 5, right? That's what it means to be inverses. So if we are being asked to figure out what n inverse of 4 is, I don't know what that is, but I know that n of that number equals 4. Right? Now, what is my n function? My n function is 2 plus g of x over 3. So n of x, g, whatever you want to call it, is 2 plus g of x over 3, and that has to equal 4. Which means g of x over 3 has to be 2. This is a y value, this is a g value, so look in your table where g of what gives you 2. Yeah. So whatever, if I want to end up with 2, this has to be -1. So x over 3 has to be -1, so x is -3. All right, what else? Yep, Mary Kate?
This is just for the quiz, but will we be able to use a calculator?
Pardon me?
Will we be able to use a calculator?
You will have to have a calculator for some of the quiz, right?
Yeah.
Because all that stuff about residuals and writing regression equations, yes.
Okay.
So, remember your AP exam is part calculator, part no calculator. Right? Right back there on that yellow sheet tells you exactly what your AP exam is gonna look like. 3 hours of sheer fun. All right, what else?
With the stuff of like, if it gives us a table, we need to write, an equation for it, will it tell us if it's like not obvious if it's linear or quadratic, which one to use?
It may not say linear or quadratic, but there will be some kind of clue.
Okay.
So remember, if something is linear, guys, when you start looking at your table, let's say they give you a table of values, what has to be the case? If it's linear, it has to be generally doing what? Either all the y's are going up or all the y's are going down. Now that isn't to say there can't be a minor variation in there, but if you've got y's that are doing this, then it's not linear, right? So, and then also we talked about there can be contextual clues in the problem itself, where if it's a football being kicked in the air, that's going to be quadratic, right? If it's, I don't know, the price I pay per pound of banana or something like that, that's gonna be linear. It's nothing tricky, certainly nothing to lose sleep over, but keep your eyes open and pay attention to what's happening.
Will it be an example of like a cubic?
Huh?
Will it be an example of a cubic? Like a cubic function?
It'll say cubic on this quiz if that's what we want, but on your exam, you're supposed to remember that you can take data points, and how do you know it's cubic? You start finding the differences in the y's, and what happens if it's cubic? The third differences match. Yeah.
This is off topic, but how is there 2 questions 30 minutes? How do you get 30 minutes for 2 questions on the exam?
That,
Essay.
well, the pre-response questions,
Yeah.
they're multiple parts. And you'll see, when we start doing practice exams, you'll see. And last year, they did not, that was the easier part of the test for the kids. The multiple choice is tricky. But no, the pre-response, we'll be so ready for that. We'll practice and practice and practice.
That essay we have to do, when's it due by?
November 22nd.
Wanna check Canvas?
Like Christmas.
November 22nd.
Oh, is it?
Yep, it's in
Friday.
Canvas.
What's it about?
I've already had some
You
submitted.
Literally one page about
Remember, I
Your
need a
favorite
hard
trait.
copy.
about yourself. It's like for you.
No, we have two. We have one at Thanksgiving and one during lunch.
What's the let one about?
Thanksgiving break. You get off Wednesday, Thursday, and Friday of Thanksgiving week. None of this has anything to do with tomorrow's quiz. All right, you good? All our issues are resolved?
For number 1 on homework, 1 through 13, 113 through 14, I don't need you to do the whole thing, but I was just kind of confused because it says this in data
I'm doubling down that
that the function represents years after 1972, so I was just confused if for 1972 on the table I should put in 0
Mashed
or
potatoes too.
even though, okay, yeah. Yeah.
Cranberry relish.
When we have to explain, like, whatever it is, we just need to say if it's like overestimated or underestimated because it's positive or negative.
It depends on, if it's a word problem, you can be more specific than that. So I'm thinking of a problem that was about subscribers to something or other. So you would say you overestimated by 2 million subscribers. But if it's just a set of data points, then yeah, that's enough, because you don't have any, unit to put
Wait,
on.
but how would you know by how many subscribers? Like,
That's what the residual is.
but usually it's in like negative 0.0 something.
Well, if it's negative 0.0 something, probably, if that's a word problem, probably those y's were percentages. And so that would be underestimated or overestimated by 1%.
Wait, so the residual gives us our over or underestimated,
Yeah,
and then
That's what the
then the
residual
R
is.
squared gives us
the
the,
percentage of the data,
okay,
or the percentage of the error in the,
yeah, and the closer to 1 is the like most accurate,
Yeah.
okay.
So if there is a unit for just data points, do you still want us to say the number, or just say?
no, you should say the number, overestimated by 0.013 or whatever it is. I think I know what you're talking about, but I might not know, I'm not sure if that's. I'm not sure. So if I look at.
Wait, like numbers versus 1C right there?
If I look at yesterday's review sheet, I have a G function that is this.
The point is
And it says, find x
it starts high.
so that g of x is -7. The k has nothing to do with it, so we don't need to worry about that. Okay? Gus, you need to pay attention because you asked this question. So, that means this is -7. That's g of x, right there, -7. So I'm gonna go ahead and add 1 and divide by 3. And this says f of something is negative 2. So I look at my table, right? And in the table, I'm gonna have x values and f of x values, and I want this to be negative 2. All right, so I'm looking at my table, and that's negative 2 when x is 8. So that means this has to be 8. The only way you can get negative 2 is if you find f of 8. X plus 2 is 8, so x has to be 6. This is a y value. Find the x that matches that y.
So could you do 1C and homework 1.12? It's along the same lines.
All right, 112, homework 1C says h of k equals 5. H is that, and I want this to be 5. I want h, I want the y value, the function value to be 5. Right, yeah. So I'm just gonna solve this, so I'll add 5. Divide. Now this says, there's my d, this says sum x gives me negative 5. That's what that says. So we look at my table, and that's 6. So that means this has to be 6. The only way I can get negative 5 is if I find g of 6. So x minus 3 is 6, which means x must be all right, so let's quickly look at the other review sheet, the one Mr. Passwater put together, which is strictly for topics 112 to 114. Let's see, well, there's some on there like we just talked about. Look at number 3, real quick. Number 3, tell me what are the transformations that are happening in problem 3? What's going on?
X's are multiplied by 2.
X's are multiplied by 2, right? So if we want to use really mathematical language, we would say we have a horizontal dilation by a factor of 2. But in terms of graphing, we're going to double all our X's. Yeah, that's what's going to happen. What else is going to happen? Y's are going to be times by 5, and then moved up 3, and you got to do it in that order, guys. PEMDAS, all right? So we're going to times by 5, and then add 3. Good. We haven't done a domain range problem in a while. Let's look at number 12. Number 12 says we've got a function k whose domain is given negative 4 to 8, and the range is negative 7 to 3. And then we got this new function called r, and we got to find its domain and range. Okay, so all we're going to do is figure out what changes we made. So what changes have we made in function r?
Multiply the x by 3.
So x times 3, all right. What else has happened?
Times 2, then plus 1.
Y times 2 plus 1, right? So instead of doing every point, we're just doing like the ends to get our domain. So if we're taking our x's times 3, would you say negative 12 and 24? And our y's are being doubled and add 1, so negative 13 and 7. Does that look okay? Yeah, that wasn't very hard, all right.
14 on the back.
14. Well, I gotta put all the data into my calculator. Oh wait, first, let's look at it. What do we think? What kind of, regression are we going to have there? Yeah, I think that looks pretty quadratic, doesn't it? Alright, so 0, 2.5, 4.9.
Is that the only way you can tell the equation's quadratic?
Alright, so I'm gonna do a quadratic regression. I hope I got my numbers in right, I was doing it pretty fast. I got 1.509 x squared, anybody else get that? Plus or minus 15.138 plus 39.997. Is that all right with everybody? Now I want to know what's the residual for the point whose x-coordinate is 6.1. So I'll go back to my stat. And I want the 1, 2, 3, 4, 5th one. Did you get negative 0.0856? Negative 0.0856 is the residual. All right. We'll have a whole period for the quiz tomorrow. You might not need it, but you'll have it. And then,